Welcome back. Welcome to lesson 7, and in lesson 7 we're going to look at how we control time. Now, in previous scripts that we've created, we've used a function called delay, but in this lesson we're going to learn to use a more advanced form of controlling time. We're going to use the function that is called millis. And the other thing that we're going to learn today, another function we're going to pick up, is the function random. Now, the best way to explain this is to go straight to the code window, so let's get the IDE open. As you can see, the IDE is already open and I've already put the basics of our script in place. Now, just so that you don't get lost, everything in the setup is the usual. We're starting the serial, I've put the script name in, and then we're going to print a blank line. Now, because we're going to be dealing with time today, I just want you to look down on the serial monitor and make sure that the show timestamp is ticked. Otherwise, how are you going to know if the timing's working? Right, let's get straight on and look down at the main loop, and there's nothing here that you haven't seen before in previous lessons. So we're going to print something, a single line, to the serial monitor. It's just got some text in, first item, and then what's going to happen is we're going to delay for 2000 milliseconds, which works out at 2 seconds. So let's just get that going, and as you'll see, it'll happen exactly as you expected. So we're compiling away. There we go. First item, first item, first item, first item. And as it goes down, I'm not going to bother stopping it. If you can see, the first time it wrote that was at 9 o'clock, 27 minutes and 30 seconds. It then did it again at 32 seconds, 34 seconds, 36, 38. Guess what? Going back to our delay of 2000, 2 seconds, that's what we're seeing there. Now you'll notice the timing isn't absolutely perfect. You can see there I've got 952 and 959. It's pretty close, but these numbers vary very slightly. Now there's a couple of reasons for that. One, when we look at what is happening here, it does take a very small amount of time to actually print first item. The Arduino's got to get that data and send it off to be displayed on the serial monitor. But the other thing that can cause an error is your computer. So my computer at the moment, to teach this lesson, has got about 4 different programs open. So my computer's doing lots of stuff in the background, so that can actually cause very slight variations in the timings here, and you just need to be aware of that right at the beginning. But if we look at what's going on, basically what we're seeing is that using a delay of 2 seconds, we see a delay between writing of 2 seconds. Now what we're going to do, because that's not particularly exciting, is we're going to change the script, and I'm going to copy and paste to save the time of watching me type badly. And basically what we're going to do here is repeat the first line. So we're going to print first item, we're going to wait 2 seconds, we're going to print the second item, we're going to wait 2 seconds, then we're going to print the third item, and we're going to wait 2 seconds. So let's get that compiled up. Now the thing to think about here, because you've probably already guessed what's going to happen, just restart the window so that it's nice and clear. So First item, wait 2 seconds. Second item, 2 seconds. Third item, 2 seconds. Fourth item, 2 seconds. Fifth item. You've got the idea what's going on. But if I just stop this for a second, or think about that, it's not going to stop because we haven't got to a scroll point. But what we're actually doing is, if we go back to our script, if I think purely about the printing of the first line, it's waiting 2 seconds, something happens, waiting 2 seconds, something happens, waiting 2 seconds. So the first line is printing every 6 seconds. And if we look here, it printed at 21:30:10, and if I go down again, 21:30:16. So each item is printing 2 seconds apart, but it's 6 seconds between each time an individual item prints. Now, that's great, providing everything is spaced evenly, because there is a problem with the function delay. When we call a delay, basically what we tell the Arduino to do is just to sit there and do nothing. So it just sits and it stops absolutely everything. Now, in a simple script like this, that's not a problem. But as you'll see in our next script, just stopping everything can cause some real problems when we want to use specific timing for different items. So I'm going to swap over to another script and we'll get started on our next part. So I've updated my script. It's now called Delay Millis version 2. I've saved the file. Make sure that I keep my versioning, and this time we're going to look at the problems of keeping exact time when work is introduced. So in our previous script we did some work, we printed to the serial monitor, we waited, we did some more work, we waited, we did some more work, we waited again. What we're going to do now is introduce a little bit more work into the screen, into the program. So integer q is back. What's an integer? It's a value that goes from sort of the minus 32,000 mark up to the plus 32,000 mark. We've seen it over and over again, and it's an ideal variable to use in loops. And the loop I'm going to introduce this time is a very small for loop, and what we're going to do is we're going to put it in here for q equals 0, q is smaller than 50, q plus plus. So we've seen this type of loop before. Q will start at 0, it'll keep going until while it's still less than 50, so it'll keep going to 49, and it'll increment by 1 for each loop. And then what we're going to do, very simple, again, you've seen it before. All we're going to do is print the value of q. So let's get that one compiled and get it running. So what we're trying to do here is we're adding some work, some more work into the program that we've written. So here we go. Seeing all these numbers appear very quickly. Third item, first item, and a whole load of other stuff. Right, stop the auto scroll. Let's go back. So we see the first item is printed at 22 seconds. And then what happens is a load of things go on here. And if you look at the timing as these numbers are printed out, the first one is 0.121. By the time the last number is printed out, we're at 0.312. So actually by now about 0.15 of a second has gone by. So the time now from the first item to the second item, instead of it being 2 seconds, it's now about 2.15 seconds. And that's because the delay starts in our script after all of these things have printed. Now, that's a little bit difficult to see the exact amount of problems it's going to cause, but what we really need to do is add a little bit more work or add something else that will mess our timing up. The reason I've put this particular for loop in is just to demonstrate to you that anything that the Arduino does takes time. It may be a very short time, it may be only a few milliseconds, but if you're trying to time something very accurately, those milliseconds can make a big difference. And it's why when you're actually putting a script, what I would call for production, so when I'm writing a script, I'll have all these different serial prints in so that I can see what's going on, I can test my code. But when I finish the code and upload it for a final version, I will comment out all of these lines to make sure that I don't waste time in my script printing out information to a serial monitor that's not even attached to the Arduino anymore. Now, to add a little bit more variation, I thought what we would do is we would use a function called random. Now, at the moment, we are going to delay for 2 seconds. What we're going to do is we're going to comment that out. And first, I'm going to show you the syntax for random. So again, let's go to our reference. The reference is always our friend. We're going to scroll down, and where do we find random? There we go, random numbers. The function random. And so what random allows us to do is we can put a minimum value in and a maximum value. You can just put a maximum that would go from sort of 0 to that value, but we're going to use a minimum and a maximum value. Don't forget the reference is always there and it's always your friend. I've just got to change that because I realize I need to move those two lines down together. So random. So if we put random, let's start at 500 and we'll go to 2500. So what that will do, what that function will do, is it will pick a random number somewhere between 500 and 2500. And then what I'm going to do, and this is how you start to see a function being used inside a function, we're going to cause a delay. And so instead of the delay being a number that we've put in, the delay is now a random number between 500 and 2500. So now we cannot predict how long it's going to take to go from this line, the second item, to the third item. So let's compile this up. And this is where you can have some real problems with using the delay, and why I'm going to show you a different method of controlling time in your program. I'm just going to close this window and reopen it so we get a fresh view. There we go, off it goes. Let it go through one more loop. That'll do. Now let's go back to the top. Now if we imagine if this first item was something that we wanted to happen exactly every 6 seconds, it happened at 28 seconds. We then go down. It happened about, this next second item has happened about 2.15 seconds later. That's because we wrote all of those numbers in the for loop. And then of course we've got the random, which bizarrely was quite close to 2 on this one. Well, it isn't actually, is it? It's more like 1.6, something like that. So when we get back to the first item, it's still roughly 6 seconds. Now if we go through the loop again, if we look at that, it's at 34. Again, it's random, so I can't control what's going to happen. But this time when we get to the next item, it's at 40. Again, roughly 6 seconds. I think I need to alter my random a bit. So it then goes 40 again. From 40 it then goes, by the time it next cycles through, hang on, now we got a better random, it's 44 seconds. So it's only taken about 4.5 seconds to loop this time. And that's because if we look at the gap between this, the second item, and the third item, the random value that was chosen only added about 0.6 of a second. Now that means that if we wanted the first item to happen at an exact timing, delay is a problem, because delay is affected by everything that goes before it, and we have no control of that. So if something changes within our program, even if you added a couple of lines of code, your timings could change. So what we're now going to look at is using a different method of controlling time that will allow each of these individual items to be controlled individually without interfering with each other. So I've reset my script. I've gone back virtually to the one we started with at the beginning. We're going to learn the basics of millis, and as you can see, all we've got is the serial print first item, wait for 2 seconds, 2000 milliseconds. Now the function that we are going to use, if we go into the manual, is the function millis. Remember, the manual is your friend, so it returns the number of milliseconds since the Arduino board began running the current program. So basically what that means is that as soon as the Arduino is plugged in, turned on, whatever, it starts a counter, and it's counting 1000 times a second. Now, as we looked at in our last lesson 6, when we were looking at different types of numeric variable, there is a very useful variable for dealing with that, and it is the unsigned long. And I'm going to call this one timer 1. Now that unsigned long can go to, what was it, 4 billion, something like just over 4 billion. So in Arduino time, that works out, using millis, it'll last for about 50 days. So if your program runs for more than 50 days, you've got to think about your code and how you're going to deal with that numeric sort of overrun, because if you remember from our last lesson, you'll be outside of your digital parking space and your number will get put back to 0. So how does this work? Well, we're not going to use delay anymore, and what we're going to use is a simple if statement. So if millis is greater than timer 1, then I want it to print this line of text. Now what would happen is timer 1, because I haven't put a value in, is equal to 0. So when the program starts, it'll go into the loop, and as soon as millis is greater than 0, it will print this line, and of course it will run round again and it will keep printing it over and over again, because millis will always be bigger than timer 1. So what we need to do is change timer 1, and this is the simple line that makes everything work. So what we put in is timer 1 is equal to millis plus, for this example, I'm just going to put 2000. We're going to use 6000 later, and you'll see why. So take the current time and add 2 seconds. Okay, so what we're now saying is the value of timer 1 is the current time plus 2 seconds. So when we go through the loop again, the if statement will say, is millis bigger than timer 1? No, it's not anymore, because we've added 2000. It's got to wait until it's looped for, basically until it's wasted 2 seconds, and then it will work. So let's get this compiled and you can see it in action. Now the important thing to remember about this is that while that if statement is not working, there we go, the information's coming down, and as you can see we have a 2 second gap. The reason that's 3 is it went from 0.99, so it's bouncing on the edge, but basically it's within an absolute fraction of being exactly 2 seconds apart, allowing for my computer doing its stuff and information being passed backwards and forwards. So the difference between this and millis is that when this runs, if millis is not greater than timer 1, the loop keeps running. If there was a delay in here, the loop literally stops for the length of the delay. Now what this allows us to do, we're going to add some more timers in. I'm going to put 2 more in. I'm going to be creative. I'm going to call them timer 2 and timer 3. We're going to copy this. Timer 2, timer 3, and we're going to serial print the second item, and we're going to serial print the third item. Now what we actually want to do is make something print every 6 seconds. So what I'm trying to do is to get it to print first item every 6 seconds, second item every 6 seconds, and third item every 6 seconds. So we're going to put the code in to do that. So we're going to change this to 6,000. 6,000. 6,000. So now it's going to be 6 seconds. Let's make sure I've updated all the comments. And that needs to be timer 3. That needs to be timer 2. Okay, so if timer 1, if millis is greater than timer 1, we want it to do this. If millis is greater than timer 2, we want it to do this. If millis is greater than timer 3, we want it to do this. And in each case, you can see we're going to reset the time for 6 seconds ahead. Now, this will have a bit of an unexpected result if you're used to using delay. Close the window and reopen it as it's compiled so we can, hang on. Now and again you get this funny error that the serial port is busy. If you get the error, just do it again. So here we go. It's still busy. Would you believe it, Houston? We've got a problem. There we go. Down it comes. Now you notice how the 3 items appeared. They all appeared instantly, and they've waited 6 seconds and they've all appeared again. There's no spacing between them, and that's because all of the values of the timers started at 0. So actually this item happens, and because there's not a delay, it can immediately get on with this bit of code and then this bit of code. So what do we do if we want to separate them? Well, what we could do is change their start times. So if we change this to 2000 and we change this to 4000, so now what we're saying is we've got an unsigned long timer 1 with a value of 0, an unsigned long timer 2 with a value of 2000, and an unsigned long timer 3 with a value of 4000. So what will happen here is it will immediately fire off timer 1 because it's saying, hang on, millis is already higher than this, let's get moving, we'll reset the timer and we'll print this item. But then it will keep looping and it will keep looping, it'll keep doing this comparison, and the next thing that's going to happen is we're going to get to 2000, and 2000 is going to be 2001 and it's going to be greater than timer 2, so it will do timer 2 and then it will keep going until it gets to 4000 and then it will do timer 3. So let's run the code. Hopefully the COM port is no longer busy and is available. I obviously have a very busy Arduino here. It's got its own social life. There we go. Oh dear, here we go again. Let's just kill it. Plug it back in. Try again. As you can see, these problems occur to everybody. Okay, here we go. No, it's blocking it again. We wait with bated breath. That's it, it's done it. Bring up the window. First item is printed. We will wait 2 seconds, we see the second item, we see the third item. Now notice between the first item and the repeat of the first item is 6 seconds. The time between the second item and its repeat is 6 seconds. So now what we're actually seeing here is that the timing of these individual serial prints, that each timer is doing its own thing. It's not being interfered with by anything the other one does. And what I'm going to do for our final example is we're going to really mess things up, and we're going to get these different timers doing different things and running at completely different times. So I'm just going to swap the screen again and we'll get on with it. Okay, the screen is resaved. I've saved my new version as delays millis version 4. And what we're going to do, so timer 1 I'm going to leave spaced every 6 seconds. Then what I'm going to do is I'm going to do timer 2. I'm going to get it to space itself every 3.5 seconds. So we're going to change that 3.5, which is 3,500 millis. I'm also going to copy the little bit of code that we had earlier, and we're going to chuck some weight into here. We're going to put that serial print. In fact, let's make it 100 just to have a bit of fun. And then finally, for this last timer, rather than giving it a fixed time change, we're going to bring our function back for random. So we're adding 6 seconds to timer 1, 3.5 seconds to timer 2, and then what I'm going to do is I'm going to allow this to be anything between 2 and 8 seconds. So this is going to be 2 to 8 seconds, which is 2,000 to 8,000. Too many zeros. So as you can see, this time round, this timer, the third timer, will be chopping and changing all over the place. I've got no control of when that is going to trigger. This is going to be triggering on a different rate to timer 1, plus we've got all this serial print going on at the same time. So let's get it compiled up and see if we get the results that we want. So the goal of this is always that everything prints right on time. Let it go through a few cycles and then we'll take a look and see what's going on. Okay, that's enough cycles. Right, let's go back to the front top. So the first item we can see at 14 seconds it fired. So what we should see now, if we add 6 seconds, we go down to 20, and lo and behold, at 20 it runs again. Okay, let's look at that first value. In fact, if we look at that first value, it was 14.013, and when we come down to here, it's 20.039. So even allowing for errors and load on the computer, it's within basically 0.015 of a second. That's pretty accurate. Now the second item was going to print out every 3.5 seconds. Now don't forget we've got our delay, so it won't do anything until 2 seconds have gone by. So after 2 seconds it starts, and then 3.5 seconds later, you see that? Now notice between the second item and the second item printing again, the first item didn't print because that only prints every 6 seconds. So as you can see now, the timings are completely independent of each other. If we go back to our variable for timer 3, that wasn't going to start until 4 seconds in. And so 2 seconds after timer 2, after the second item, the third item kicks in. Now we then see the first item again, and if we go down, we have no idea to a degree what order these will appear in. We know that the second item will always be every 3.5 seconds. We know the first item's always going to be every 6 seconds, but the third item can jump randomly from one position to another because we just don't know what's going on. And there you see an example of it. The second item's managed to print twice, the third item's in the middle, and then the first item is after. They're all keeping their own individual timings, but they never interfere with each other. And that is the advantage of using millis. Millis allows the processor to keep running non-stop. And at the moment I'm using the example of serial print just to help you to get an idea of what is going on. But in here we could be starting a motor, we could be stopping a motor, turning a light on, reading a sensor. Each time you see the serial print, we could be doing some function of some type within our program. But as you can see, we can now control the timings of those functions independently of any other function that's running. So here we've got one item that's running every 6 seconds, I've got another thing running every 3.5 seconds, I've got another one that's running at random times. And the great thing is, if I suddenly change the timing here, it will not affect the timing of this function. If you think about delay, if we shortened the first delay or changed the first delay, it then affected the timing of everything else in the program. The great beauty of millis is that each timer is running on its own, and so your functions can all be timed individually. So I hope that's proved useful for you. Millis and delay seem to be one of those things that beginners really struggle with. As you can see, it's not particularly complicated. The function runs very simply. We have an if, so if the value of millis is above the timer value, put my line in, we then take the current time and add 3.5 seconds to reset the timer. We do the work that we want done within this little section of code, and then we just let it move on and it will get on with the next job. So that's basically what is happening here. It's very, very simple. You could have all sorts of things. So when we do our robot car, there will be sections where we will use millis to decide when we're going to fire our ultrasonic sensors. We might use millis for when we move a servo. We may even use millis for when we move the motors, turn them on and off. So all of these things can all be individually timed with millis, and as you can see, once you can get your head round the fact that it's all in its own separate bits of code, all is well. Now, what I will tend to do here, I've used timer 1, timer 2, timer 3. Now let's imagine that this is controlling a servo. I wouldn't call it timer 2, I'd call it servo timer. If this was doing the ultrasonics, I'd call it ultrasonic timer, and if this one was doing the motor, I'd call it the motor timer. So again, use the name of your variable to describe what the timer is actually doing. So in this lesson today, we've learnt to control time. We've seen how delay works. We've also seen the problem with delay and how it stops the program, and that how altering a delay in one area of our script affects the timing of everything else. We've then looked at millis, and we've seen how by using millis, different parts of the program can run on their own distinct timing. And then also, as an added bonus, we've seen how the function random works, how you can have a start value and an end value, and it will give you a random number that's generated from within that. So I hope this lesson has been useful for you. As I've said before, delay and millis does seem to be one of those things that does get confusing for a lot of beginners, but if you can get into the habit of using millis, you will do yourself a favour in the long term. So thanks for listening, and hope to see you for lesson 8.